Welcome to the Stem Cell Donors Australia podcast.
Ever heard stem cell donation and thought, I get the idea, but what does it actually mean? In this episode, Carmel O'Brien, Chief Scientist at Stem Cell Donors Australia, breaks down the science behind blood stem cell and bone marrow donation in plain language. No medical background required. Carmel, welcome to the podcast.
Hi, Dan. Thanks for having me.
Thank you for joining us. To start off with, did you want to just introduce yourself and tell us a bit about the work you do at Stem Cell Donors Australia?
Yep, sure. So I'm a lead scientist with the registry, and my role is to keep us all across the current science globally that's going on in stem cell transplantation, and also ensuring that we make really good decisions around the way we build our registry so that it gives everybody in Australia the best chance for receiving a life-saving transplant should they need one.
So at this stage, most people have heard of stem cell donation, but the science behind it can feel like another language sometimes. There's a lot of sort of complicated concepts and ideas to get your head around. Today, we're sort of going to walk through some of those concepts and get you to sort of explain them in lay terms so that people can get a better understanding of what is actually involved. So the first question for you. So when you talk to people in your everyday life, people who don't know what you do for work, what's the one concept that they often get the most confused about? What's the hardest thing you find to explain to someone about stem cell donation?
Thanks, Dan. So I love sharing my love of stem cells. I think the most common confusions I hear when I'm in conversations about stem cells is what is even a stem cell, what types there are, different types, and how they are matched and collected. So there's a lot of confusion about that in conversations. And I think when we talk about stem cell transplants, the biggest misconception I hear in those everyday conversations is the type of stem cell involved, and also that the stem cell collection itself might be a really complex or even a painful procedure. So it'd be really good to clarify some of those things today.
You're so right too. Yeah, there's a lot of talk about stem cells in the media and news these days, isn't there? Because they're used for a lot of different sort of applications. So those are the big sort of two concepts we're tackling here, aren't they? It's bone marrow and blood stem cells. So can you tell us what are blood stem cells and where do they come from?
Yep, sure. So when we talk about blood-forming stem cells, we're talking about a particular superpower type of stem cell. Let's step back a little bit and say, what is a stem cell? So by very definition, a stem cell has two key properties. The first one is that it can keep making itself. It can keep replicating itself over and over and over again during your lifetime. So it's a really important superpower. The second property is that when it's given a particular instruction by the body, it will then make all of the other types of cells that it's been destined to make. So when we talk about blood stem cells, we're talking about a blood master Yoda cell of the universe that knows how to make red cells, white cells of the immune system, and also platelets, which are part of our clotting system. So the master blood-forming stem cell can keep making its own self over and over again, like keeps replenishing its commanding workforce, and then it can continue on a daily basis to make millions of all of its offspring, which make up the blood system. So that's its job as a blood-forming stem cell.
And so how do blood stem cells relate to bone marrow then?
Yeah, that's a really good question, and I think that's where some of the confusion is. So let's think about the bone marrow as where the blood stem cells live. So that's where they're housed. I like to think of the bone marrow as like a super factory. It's a place inside of some of your large bones, not all, mainly around your hips and your spinal cord and your chest. That's where the bone marrow is. It's a spongy part deep inside your bones where all these little super factories sit. And that's where your master Yoda blood stem cells are living all the time. They're pretty much tethered there. They don't really go out into the bloodstream. There'll always be a tiny number that are circulating, but they're pretty much tethered to the factories to do their job of making themselves and on a daily basis making all of those blood system cells, the red cells, the white cells, the platelet, that are pumped out into the blood on a daily basis. So let's think about the bone marrow as the house or the home of these super factories.
Okay, so why would somebody need these stem cells from another person?
Yeah. So what happens when that factory where our stem cells are busy on a daily basis making themselves and making the blood system, when that starts to fail, there isn't that daily replenishing of your blood system. So if somebody has a disease either directly of their bone marrow factory or a blood disease where their blood is not in good order on a daily basis and it affects the bone marrow, that whole system is in need of basically a rebuild. So the patient is not going to be cured by having a fresh blood replacement every day because the factory is broken. So in a situation, often that's like a blood cancer, or it can also be a non-cancerous disease that actually affects the bone marrow, so bone marrow failure of any sort. Also sometimes in an autoimmune disease, the bone marrow can be impacted. Any of those diseases that actually stop a person's own stem cell factory from thriving and doing its daily job is when somebody will be offered a transplant as their hope for a second chance.
So you say a blood stem cell transplant can be used to treat these sorts of conditions. Can you tell me a bit more about sort of the treatment path to get there? Because we often say that a blood stem cell transplant is the last option for a patient living with one of these conditions.
So when a patient has a breakdown in their own bone marrow system, so their own factories are breaking down, they're in a situation where their health is seriously impacted because they're not able to replenish their own system. So usually that patient has been through a pretty significant treatment pathway, which may include chemotherapy or other treatments for their disease. And essentially a transplant is going to be their last option for actually rebuilding their own immune system and their own master progenitor system so that they can actually rebuild their own blood system again.
So can you tell me a bit more about what a blood stem cell transplant actually does for a patient? How does it work?
So a blood stem cell transplant is actually a complete replacement of the patient's own factory, if you like. We talked about the super factories being in the bone marrow. Their bone marrow is not working effectively, and so they don't have any replenishing mechanisms. So when somebody has a transplant, they are accepting in new cells, completely new healthy master cells from a donor. So not just blood cells, but the master stem cells. And those cells go into the patient's body, and they very cleverly find their way into the bone marrow of the patient and set up a whole new factory system and start, eventually over about 3 or 4 weeks, they start to make their own, as we said before, they make themselves over and over again. So the donor stem cells come in, set up a factory and start making themselves, and then they start to propagate the patient's system with the whole new blood system. So it's effectively a complete replacement of the patient's immune system and blood system.
It's quite amazing, isn't it, the science behind it? I try and explain it to people sometimes, and it's the best sort of comparison I can make is it's sort of miraculous, you know?
Oh, that's why I love talking about stem cells, because they are incredibly powerful. And I think it's important here to really delineate that it's not a replacement of the blood. It's actually a replacement of that whole system that makes your blood on a daily basis. So the overarching superpower that does that.
So that sounds like a blood stem cell transplant has a really sort of big job to do in the body of the patient. And I guess that's one of the reasons why matching is so important, right?
Yeah, so matching is really important in a transplant, and this is where it's a little bit different to the blood system. It's not the same as matching a blood type. You would have heard of A plus and O and that small group of blood types that when you have a blood transfusion. When you have a transplant, you're talking about your defense system. So let's just step back a little bit and we'll talk about the immune system. So we're all born with little things sticking up on all of our cells right throughout our body. We've got our own signature, if you like. I like to think of this as like our own personal identity tag or a QR code. And what this is it's a system that you inherit from your mum and your dad, and it tells the body if something coming into your body is foreign or it's part of you and it's okay to accept it. So, for example, when you get a cough or a cold, you're influxing a bug or a virus, your body's identity system says, hey, I don't recognize you. I'm going to set up a defense response here. And that's where all those blood system white cells go into action like an army and they start defending you. So when you have a transplant, somebody else who's giving you their master cells, they have to look a fair bit the same as you to be accepted into your body. Otherwise, the patient is also going to go, hey, I'm not accepting these new master cells into my body. and they set up a defence response. So it's really important that the identity tag of the donor and the identity tag of the patient are pretty similar. And that's a really important part of the matching. Yeah.
And so when we talk about that matching, that's where I guess the concept of HLA markers come in, right? Can you tell us what those are and what role they play in matching a patient with a donor?
Yep. So HLA, let's demystify that term, that's human leukocyte antigen. And that is another way of talking about this identity tag that we've just talked about. Let's call that our QR code. That's the thing that is represented on every cell in our body, or most cells in our body, that is our signature. If you want to get really nerdy, it's something that's inherited from chromosome 6, part from your dad, part from your mum, and it's a very complex part of chromosome 6. It can be in all sorts of coding combinations, but you end up with your own template that says, hey, this is my immune system. If you're coming in, you need to be a pretty good match for me.
Right. So those HLA markers are sort of the run sheet that we use to compare between the donor and the patient. And if they're a close enough match, then we know a transplant is likely to be successful?
Yeah, very much, Dan. So they're actually proteins that stick up on all of our cells, but they're coded by this template that we've inherited. And they do need to be a pretty high. The higher the match, the better the transplant outcome will be.
So I guess it's a little bit like DNA in that way, right? In that we each have our own unique DNA, but this is sort of a more specialized version of that?
Yep, so it's a really good way to put it. This QR code that we're talking about, it is actually a bunch of proteins that stick up on all of our cells. Proteins are coded by DNA. So yes, to be nerdy, we're talking about this little part of chromosome 6 that genetically tells us what our template is, what our particular blueprint is for immunity. And so we inherit that, and a donor and a patient need to be highly matched for a transplant to proceed.
So you mentioned that HLA markers are inherited from our parents. Can you tell us what that means for finding a match for a patient?
Yeah, sure. So we know that the area of the chromosome 6 where we inherit that identity from for our immune system, we know that that's strongly linked to your ethnic background and so you've inherited that from your parents, they've inherited it from their parents, and so on and so on and so on. So there is a strong linkage between ethnic background and that coding that you end up getting, which is half from each parent. So you can see the combinations of coding become, extraordinary, really. So there's thousands and thousands and thousands of coding combinations that could present, and we know that there is this ethnic linkage. So you are more likely to find a match with someone who comes from that same sort of ethnic background as you. And as our societies become more and more diverse, those codes become more and more diverse. And that's why it's really important for our registry to also be diverse and representing as many codes as possible.
And that's why we talk a lot about needing to have a diverse donor pool in Australia.
Well, we know our registry is overrepresented for European backgrounds. So it's really important that we continue, and we do put a lot of effort into this, but that we continue to really build diversity into our registry so that more patients from that very diverse background have a higher chance of finding a suitable match from our registry. And that is a global situation. All registries globally are working hard to increase diversity.
Okay, so we've talked a bit about sort of the importance of finding a good genetic match for a patient. Let's go back now to the transplant itself. So we were talking about blood stem cells being in the bone marrow, but stem cell transplants aren't often done via bone marrow these days. Can you tell me about sort of that process?
Yeah.
How do we get the stem cells from bone marrow and then into a patient via their vein?
Yeah. So they're sitting housed in the bone marrow, right? And I said to you earlier that they're tethered there. They're pretty much told to stay here in the factory and do your job unless you're called upon. So even in times of injury, there's still not a lot of stem cells circulating in the blood. So how do we get them into the blood? Or how do we retrieve them? So there are a couple of ways you can retrieve stem cells. Traditionally, it's been by bone marrow biopsy, so direct collection from the middle of the bones. But most commonly now, and in about over 90% of transplant cases, this is done by collecting blood. So how do we get the cells into the blood? So a donor, if they're identified as a match, they will have a medical injection. It's a bit like a growth factor, hormone growth factor, that actually it does a couple of things. It gets the master stem cells in the bone marrow factories to really amp it up and start making lots of themselves quickly. And then the second thing they do that medicine does is to pump them out into the blood system so that they're actually circulating around your body and they can be easily collected by your blood collection, which is not a normal scenario. So a donor will take that medicine for about, it's an injection, they'll take that for 4 days before they donate their stem cells. So the idea is to really make as many as you can, get them out into the blood so we can collect them. And that is the most usual way now of collecting stem cells.
And that is a question we get asked from potential donors is, this idea that am I losing part of myself? Is it something, irreplaceable that I'm donating?
Okay, so the answer is no, you're not losing anything. Because remember, a stem cell, by its very nature, will keep making itself over and over and over again. It's a supercell. The more you give away, the more it's going to make itself. So, no, you are never at loss of losing yourself. So if your factory is healthy, your bone marrow is healthy, you will always be replenishing. And the medicine that's being given to a donor to get them out into the bloodstream, that's a very temporary treatment. So your bone marrow will just go back to doing its normal thing of replenishing the blood every day.
It's funny, I was talking to someone earlier and we were comparing blood stem cell donation to organ donation. We were it's a lot less permanent.
Yeah, it's a different, an organ is a whole sort of system replacement, whereas this is actually a retrieval of cells out of the factories into your blood system.
So generally speaking, there's 2 types of stem cell transplant, and this is where I think some people can get a bit confused. We talk about there's a blood stem cell transplant and then a bone marrow transplant. Can you tell me the difference between those 2?
Yep, and here I'm going to point out a confusion because it's actually the same thing. It's still a blood stem cell transplant with stem cells. How we get them, how we collect them is different. So in the majority of cases, we collect those stem cells by giving an injection of a hormone that amps up the production and pushes them out into the blood so the person can have an outpatient procedure, which is very much like a long blood donation to collect their stem cells. The other approach is to collect the stem cells directly from the bone marrow itself, so from the factory. And in that procedure, the donor would have a general anaesthetic. So they won't feel that, but that's by a needle into the bone to pull out the stem cell. But at the end of the day, you've still got the same stem cells that go into the transplant for the patient.
Okay, let's talk a bit more about the first process you mentioned and the fact that there are injections involved. When some people hear that, they get a bit scared because it is an injection and it's something you have to do for 4 days before the donation itself. Are there any sort of side effects from that medicine? It sounds like it's doing a lot in your bone marrow to pull those stem cells out.
Correct. If you think about it, your bone factories are working really hard. They've been told to amp it up and to get stuff pushed out, which isn't normal. Like they're usually just living in that factory. So they're cutting the ties to the factory. They're getting out there. So your bones are pretty busy. So it's pretty normal to feel a bit tired, maybe a bit achy in your muscles or your bones, maybe a bit like a flu is how it's been described. I obviously haven't lived it, but I think those symptoms dissipate as soon as that short course of 4 or 5 days of injection has stopped. So there's no longevity of those symptoms.
And so I guess that comes into another thing I did want to touch on. We talk about these injections are happening in the 4 days leading up to donation day. So that suggests that timing is very important when it comes to everything around this sort of donation process.
Yeah, so timing is important from a couple of angles. The first is that the patient is obviously depending on this transplant to go ahead as their chance to have a rebuilt immune system. The patient has typically been through a fairly significant path of medical treatment to be ready for that transplant. They may have been through a course of cancer treatment. They need to be healthy enough to receive the transplant, so they need to be in remission if they're on a cancer journey. On a non-cancerous situation as well, they also will have been through treatment. So they need to be well and ready in time to receive this transplant. That also means that the donor needs to be scheduled in the same way in their 4 to 5 days to mobilise that stem cell force out into their blood. So it's all lined up and timed so that the donor will be ready in the right time frame for the patient to receive the incoming stem cells.
So as we alluded to, that's the process by which we collect blood stem cells most of the time, majority of the time. But sometimes a donor will be asked to donate via a bone marrow biopsy. What decides that? What determining factors
Yep, that's very much a clinical decision that's always putting the patient's best outcome first. So what's going to benefit the patient the most? So a doctor will make that decision. Typically, that decision is made for a very small child or a baby that's got a very low body weight where you don't need as many stem cells and time might be the issue. So in that case, you can directly retrieve stem cells from a donor's bones, and that would happen under general anaesthetic. So the donor won't feel that, but that's a surgical procedure. And the other situation it might happen is where a donor has had the medicine to mobilise their master stem cells into the bloodstream, but it hasn't been quite as efficient as we would have liked, and so we don't retrieve enough stem cells. And that's an important factor that a doctor decides, and there are very clear global guidelines around what's a suitable number of stem cells per body weight for the patient. So in the situation where we haven't quite collected enough stem cells from the donor, there may be a decision made on the day to also, with consent of course, to retrieve extra cells from the bone marrow. But more typically, that donor would be asked to simply come back for a second day of collection to just get a few more stem cells. So typically, I would say the bone marrow, in Australia at least, the bone marrow collection most often happens for small paediatric patients.
So that's been a bit of an overview of the science behind blood stem cell donation. Hopefully that's opened your eyes a little, helped explain the concepts a little more simply. Carmel, thank you so much for joining us. Before we go, I've got one last question for you. If listeners remember one thing from what we talked about today, what do you think it should be?
Well, thank you, firstly, for having me. It's always a pleasure to help people understand more about stem cells and what they do. I think in terms of blood stem cell transplant, just remember that stem cells are really superpower cells. They will keep making them more of themselves through your lifetime. So it's actually really easy to donate these to someone whose own master stem cell production factories are not working. And in that way, you can really help someone, you can really help save their life.
And that's ultimately what it is, isn't it? Yeah, a successful transplant will save somebody's life. All right, thanks again, Carmel. I appreciate you taking the time out to chat with us today.
Pleasure. Thanks, Dan.